Hey guys, welcome to Revise Right's YouTube channel, and in this lesson we are going to specifically cover balancing equations, and this lesson is related to GCSE Chemistry, so if you're wanting to study anything else, then I suggest checking out another video of ours. So balancing equations can always feel tricky. Now, I have not met a student yet who's actually said that they are crazily confident on balancing equations after just studying it at school. So hopefully this video provides a step-by-step approach that makes it a lot more manageable. So one of the key things for balancing equations is we need to just understand what a general scheme of an equation looks like. So typically in an exam, you would have some reactants coming together, and let's just label these as A and D. So on your left side, always are your reactants. And then of course, on your right side are your products. Now, what we need to make sure of is that whatever we put into the reaction, i.e. A and B, we need to get out of the reaction. So that is just a basic kind of law. That's actually called law of conservation of mass. And if you head to our website, reviseright.io/opt-in, we are soon launching an e-learning platform, and that will walk you through exactly all of that. So law of conservation of mass is essentially this idea that whatever you put in needs to equal whatever you put out. And it's exactly the same when we balance equations. So essentially whatever we put in, whatever's on the left side, needs to also be reflected on the right side. Now, if we break this example down a bit more granularly, a lot of times in an exam, you will see numbers like this. And these are called coefficients. Now, why these are super important is they help you balance the equation. Now, the reason why that is let's just say, and we'll keep this again very basic, let's say that I have 3a plus 3b, and that goes into 3a plus 3b, something along those lines. Now, as you can see, we have got 3a's on the left side, but we've also got them on the right side. And what that means is that the A's are balanced. And we could say exactly the same thing for the B's. We've got 3 on the left, 3 on the right. They're both balanced. So let's actually practice this in a real life example, and a very common one that you typically get asked at GCSE level is the reaction of sodium with chlorine. Now, sodium and chlorine come together and they get sodium chloride, so that is table salt. And the reason why it says Cl2 is because naturally chlorine likes to be in something called a diatomic state. So whenever you see chlorine, it tends to be in this diatomic state, which means that there are 2 of them in nature. Now let's break this down. So on the left side of the reaction, what I'm going to do actually is break it down like this. So on the left side of the reaction, I'm going to count exactly how many atoms I have. So sodium, I have 1, and chlorine, I have 2. And I'm going to do exactly the same thing, but on the right side. So sodium, I have 1. And chlorine, I have 1, because on the right side there's only 1. Now, as you can probably see from that, the only thing that doesn't balance currently is the chlorines, and we need to change that. And this is exactly where coefficients come in. So as we can see, we basically need to gain a chlorine on the right side to make that equation happy. Now, how can we do that? Well, we add coefficients. So we need to add a number here that basically can change that number. Now, if I put the number 1 here, for example, that wouldn't do anything because essentially it makes the reaction stay the same. There's only still 1 sodium and there's still 1 chlorine. However, if I put, and let's just say I remove this, if I put a 2 here, it changes the number of both the sodiums and the chlorines on the right side. So now I have 2 sodiums and now I have 2 chlorines. So now we can see that the chlorines are actually balanced. But what is no longer balanced? Well, it's now the sodium. So now we need to deal with that. So what we need to do, very simply, is we've got 1 on the left side, 2 on the right. So what we could do is add a 2 before the sodium, and that will make sure that this turns into 2 and everything is now balanced. So that's a very, very quick overview of how to balance equations. Now definitely stay tuned and subscribe to this YouTube channel for more videos like this. We're going to be posting several times a day, so make sure to tune in for some more GCSE and A-level exam tips. And make sure to head to reviseright.io/opt-in to join our waitlist for our new e-learning platform launching very soon. Thanks guys for watching and have a great day.